Now student, let us see the new AM classification schemes as per ASTM 42, F42 and ISO TC261. So the first classification, new classification we are having VAT photopolymerization, which is also known as stereolithography or stereolithography apparatus or VAT photopolymerization. So it is widely recognized as the 3D printing process. Okay, this is known as or recognized as the 3D printing process. So it is actually the laser based process that works with these photopolymer resins, and this resin react with this laser and cures to form a solid object. Okay, so this is wet photopolymerization. So it is generally accepted as being one of the most accurate 3D printing processes, and with excellent surface finish we are getting with this uh, SLA or SL or VP. Okay, so what are the limitations of this VP are we require the post processing steps. So for example, the cleaning of unnecessary resins, cutting the unnecessary unwanted parts. Okay, then the stability of the materials over time may more brittle. So these are the limiting factors basically of wet photopolymerization. Then we are having next classification as the powder based system, that is powder bed fusion or the sintering. So we are having the wider range of materials which can be used in this powder based system, and also different functional parts we can able to produce by this powder bed fusion or sintering process. So here the laser sintering used in the polyamide, titanium and rubber like materials. The laser fuses the powder while the rest as a loose powder. So here the powder of the material to get made is fuses by the laser, and whereas there is actually the powder bed, onto that the lasers are inciding, and the parts which is going to produce that part of the powder is going to fuse only, and remaining part of the powder or remaining powder will be as a loose powder. Okay, so after one layer, a new layer of fresh powder is sprayed over the surface by a roller. We will see, definitely we will see this process, and no supporting structure is needed as unmelted or unsifted powder is used as a supporting material. So this is basically advantage of this technique, where we need not to have any kind of support to the product or prototype that you are going to make, because the powder itself will act as a supporting material, which may be the loose powder or the unmelted powder or unsintered powder is act as a supporting material. See here, some I have shown here some pictures. These are the part made by this powder based system or the powder bed fusion or sintering process, and the person is cleaning this unsolidified or the loose powder from this um, part is made. And here see the entire bed, see no any supporting structure at this base, no any supporting structure, only this unmelted or unsintered powder is acting as the support material for this process, isn't it? So the following additive manufacturing system will fall under the category of the powder bed fusion or sintering technique. So very famous is selective laser sintering SLS process. Then also we are having the color jet printing CJP. Then we are having laser engineering set shaping lens, and the fourth one is electron beam melting EBM. But out of these four, this selective laser sintering is very popularly used. So the third new classification we are having the material jetting and binder jetting. So this is most professional prototype technique. Multi materials can be used, and in this technique we are also use the different colors to make the prototype or model. So let us start with the material jetting. So here the print head, which is similar to inkjet printing, print head distributes the droplets of photosensitive material, and these droplets are getting solidified under the UV light. Support structure is required to support the liquid material. So as like in powder bed fusion technique, we need not to have any kind of support, but here we require the support structure to build a prototype. The material used are thermoset polymers, these are the acrylics in liquid form are used. So here what are the material? Material is a thermoset polymers that can be used in the material jetting. Now let us have some detailed discussion in the selective laser sintering technique. Definitely we will discuss because this is important. The selective laser sintering, SLS. So what is the layer thickness here? We are getting the layer thickness nearly 100 micron or 0.1 millimeter thick. The part building takes place inside a closed chamber filled with the nitrogen gas. Here how the part is built, it is inside a closed chamber which is filled with the nitrogen gas. We will see the diagram of this SLS. The powder is building platform is kept at elevated temperature. So here the powder in the building platform, these powders are kept at the elevated temperatures. Then infrared heaters are used to maintain an elevated temperature around the part being formed. So how this temperature is maintained? By using the infrared heaters. See here the diagram. This is the schematics of the SLS process. So this is the build platform which is filled with the nitrogen, and these are the feed cartridges which is having the powder which are going to use. Okay, so this is the roller, this is powder leveling roller. Okay, and these are the CO2 laser we are using here. These are the this is the laser beam which is incident on this powder bed. Okay, and this bed get fused. Okay, and once it get fused, this powder leveling roller will move or rotate. Okay, and will distribute the powder. Okay, then when it is distributing powder, it will reaches here. So again the process will carry out, and by how much layer it is the part is made, the build platform will go down, take it down, and another layer of the powder will be melt or fused to along with the previously made layer. So it's layer by layer approach once again. So after again this powder bed is fused by this laser, the roller will again move from roll from here to here. Again it will supply the powder. These two are the powder cartridge, actually feed cartridge. Okay, so once again the process can be continued till the entire uh, the depth of the product is achieved. Okay, so this is the SLS. See here, a focused CO2 laser beam is moved on the bed in such a way that it thermally fuses the material to form the slice cross section. Surrounding powder remains loose and serves supporting. As we discussed that in this powder bed fusion, we need not to have any kind of support system, as the unsolidified or unfused powder is acting as a supporting uh, structure for this part. Okay, so see this is the part, the picture shows the part made up of this technology, SLS. What are the advantage of SLS? So it is a self-supporting, no additional support required. The part possesses high strength and stiffness. The will have a good chemical resistance. This is the fastest additive manufacturing process. The disadvantage is that SLS printed parts have surface porosity which can be sealed by applying sealant such as cyanoacrylate. So the only thing is that the surface is having the porous uh, characteristic, but that can be sealed by the applying sealant such as the cyanoacrylate. Okay, so next is the binder jetting. Okay, in the material jetting and binder jetting we learn the material jetting. In that we learn this SLS technique. Now in binder jetting, so here instead of using of the base material as a liquid, in the case as selectively deposited on a powder bed, bonding these areas to form a solid part. Okay, the common material used are the metals, sand and ceramics in a granular form as a base material. So here also no support structure is required, it is just a powder bed system. It is just a powder bed system. Next we are having the next classification, we are having the directed energy deposition. Now here, to make the large parts with the additive manufacturing system, the powder based system is limited because its cost and the time required to build the part. A coaxial feed of powder or wire to laser or electrobeam to form a melted or sintered layer on the substrate. The powder deposition is synchronized with the heat source. Okay, so here we do not use the powder bed system. Okay, thank you.